Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Fiber Optic Communication. So in the last video, we learned about what is fiber optic communication. So we know that the communication using the wire is known as the fiber optic communication. So now we need to learn about the few more things related to the fiber optic. So we are going to start with the overview of the optical fiber communication, and in this video you will learn about ITU spectral band, evolution of the fiber optic system, and basic structure of optical fiber. So now, ITU spectral band, International Telecommunication Union, they had designated the 6 spectral band for the use in the fiber optic communication. So these spectral bands are the O band, then it is the original band, and the wavelength, that is the 1260 to 1360 nanometer. The E band, that is the extended band, it is 1360 to 1460 nanometer. It is the S band, short wavelength, 1460 to 1530 nanometer. C band, that is the conventional band, it is the 1530 to 1565 nanometer. L band, that is the long wavelength, and it is the 1565 to 1626 nanometer. And the U band, it's a ultra long, the wavelength band, okay, and it is the 1625 to 1675 nanometer. So according to this band, okay, the various applications that are implemented in case of the optical fiber communication. Now, the question is about the evolution of the optical fiber system. So now, this optical fiber system was started since the year 1792. In that, the French scientists, they invented the optical telegraph, the semaphore they designed. Okay, and that is for transmitting the information, okay, in the visual form using the tower. So now here you can see the tower, and using that tower the people can do the communication. So it is the mounted semaphore system which is used to convey the information in the visual form on the tower. Now the next system, that is in the year 1880, the Alexander Graham Bell, they invented the optical telephone system, and which is known as the photophone, because transmitting the information in form of the light. So it is the photophone. So such kind of the system that is invented in the year 1880 to 1880. So now this particular system they invented, but the drawback of this optical telephone system, that is the lots of the disturbance when the light was transmitted through the air. And another thing, that is why due to the disturbance there is a need for developing the ordinary telephone. Okay, so that is why the invention of the ordinary telephone that became the more popular. Then after, in the year 1900, the inventors they proved that the band quartz rods that can carry the light rays. So such kind of the quartz rays that invented, and by which the information that can be transmitted in form of the light. In the year 1920, the medical student in the Munich, made the use of the optical cable bundles to transmit the medical images. In the medical, they started the use in the very particular application which is known as the endoscopy. So the bundles of the wires, they were sent into the human body, and then after the affected part that can be observed onto the screen. And by sending the laser light with them, the surgery that can be done using the LEDs and as well as the lasers. But such kind of the drawback of the optical cable bundles, that is the transmission of the images through the unclad fibers, that was very poor. Okay. Then after, in the year 1951, the Lawrence Curtis developed the glass-cladded fiber. And such kind of the glass-cladded fiber, again, they provided the amount of the attenuation while we used for the communication. So this is again the use of the optical fiber in the endoscopy. So here you can see that the bunch of the fiber, they inserted inside the human body, and you can see the parts inside the body, and we can have the idea about the particular disease. Again, by inserting the laser light, so only we need to do the punch onto the human body. So it's invasive the surgery, by use in the endoscopy. So this way we can also use in the endoscopy. So this way the optical fiber that can play a big role in the communication. Then in the year 1970, the glass fiber was developed, and this kind of the glass fiber that is developed, and it produces the very low loss for the signal transmission, and it is the 20 dB per kilometer. So that the 1% of light remained in the fiber even traveling the 1 kilometer distance. So this way, in the 1977, the telephone companies, they started replacing the old copper wire with the optical fiber cable. So here you can see that the images of the copper cable and the optical fiber cable. So these are the various kind of the evaluation in the case of the fiber optic communication, and we can see that it's a very thin wire like the human hair, and the compact size, that is again the advantage, the lesser loss compared to all copper cable. So what is this? It's a copper optical wire fiber is a hair thin cylindrical fiber of a gas or any transparent dielectric medium, and that is used for transmitting the signal. So the fiber which are used for the optical fiber communications are a waveguide, and it's made up of the dielectric transparent material, and the function that is to guide the visible and infrared light over the long distance. So here you can see that this is the optical fiber, which consists of the core, cladding, and the outer coating, sub-outer coating. So this type of the three main parts available with the optical fiber. So in the basic structure, the three parts are there: core, cladding, and the outer jacket, or it is known as the buffer clothing. Now what is the function of all these the parts? So very first, inner part of the fiber optic cable, that is the core. So it is the glass, thin glass center of the fiber in which the light that can be traveled. The core that has the higher refractive index than the cladding. We will see in the the next chapter, that what is the refractive index. Okay, mean how the wave that can pass through that kind of the medium. So whether the medium is rarer or the denser, depending on to that the wave that can be traveled from the material. Okay, so the core that is having the slightly higher refractive index, okay, than the cladding. Okay, the sometimes the plastic materials that can be also used. So plastic fiber, glass fiber. Okay, so according to the fiber, the material that is used to make the core as well as the cladding. What is the cladding? Cladding, the outer optical material surrounding the core that reflects the light back into the core. Okay, now this core that is mainly provide the strength to the optical fiber, because the optical fiber installation that is under the ground. So we know that the under the ground, the too much pressure that is applied onto the optical fiber. So the optical fiber should have the higher strength. So that what happened, that whenever the some pressure is applied, again it can protect with such kind of the things. Again we are putting that undersea installation. Okay, so at that time we know that the animals are there, the water animals are there, the ships are going. Okay, so to protect from everything, the structure of this kind of the material, that is the strength. So it gives the strength to the optical fiber cable. It can also act as a mirror, so that the light rays that gets reflected from it with no power loss. So that is why the core and the cladding. Now the buffer coating. Sometimes we can refer to that as a jacket. Now we can wear the jacket to protect ourselves, okay, with the atmosphere, okay, with the weather. So that is why similar thing that is with the fiber also. That is a fiber optic cable that has an additional coating around the cladding, that is called the jacket. And the plastic coating that protects the fiber from damage and the moisture parts of the fiber optics. So sometimes the Kevlar material that is used as a jacket, okay, and it can protect the fiber optic cable from the atmosphere, from the whatever the changes that is applied in the atmosphere. So this is regarding the evolution of the fiber optic communication and the basic structure of the fiber optic cable. So thank you very much everyone.